Welcome back, Physics 30. This is the last booklet in the acceleration section, part 5. And we kind of touched on this already with the previous little graph matching booklet that I had you do at the start. We talked about average acceleration and instantaneous acceleration. So now we'll look at velocity versus time graphs to determine both of those items. And you may be experiencing deja vu because it's very similar to figuring out average and instantaneous velocity on a PT graph. Okay, so examining the following VT graph. Now mine's kind of cluttered up here. Yours is nicer. I got a little crazy with the flower power here, but just ignore that for now. So at what time can you tell that the acceleration is 0? Now again, here we're looking at slope. So acceleration is slope on a VT graph. So where would the slope be 0? There's actually 3 areas here. If I was to draw a tangent line in this point here, that would be a flat line. Over here, flat line. And over here at the top here, that's a flat line too. So 3 different sections there. And those all correspond to be 9, 13, and 18. So 9 seconds, 13 seconds, 18 seconds, where those tangent lines would have 0 slope. So I kind of explained that already there. Instantaneous acceleration is 0 where there is a 0 slope for the tangent line. Okay? What is acceleration for the first 7 seconds? So in other words, from 0 to 7 seconds. So here we're looking at, now your graph should be fairly straight here. So 0, 0. And I think the point here that corresponds to a time of 7 is 5. So T1 or T1 V1, T2 V2. So 5 minus 0 over 7 minus 0. So you can see we get plus 0.71 meters per second squared. Now over to the average acceleration parts. So what's the average acceleration from 5 to 15? So 5 to 15, I figured out to be around 5 comma velocity 3.5. And over here at 15, it corresponds to about 7.5. So really what we're doing is we're figuring out the slope of this red line which joins those 2 points. So T1 V1, T2 V2, V2 minus V1 over T2 minus T1. So 7.5 minus 3.5 over 15 minus 5. So do that and we get plus 0.40 meters per second squared. From 9 to 13, maybe pause the video right now and you try that and see what you come up with, and then see what the answer is here. Okay, if you had a chance to look at that from 9 to 13, so 9, and I got about 9 and 6.72. 13, it's on at around 5. So we're looking at this green line here that joins those 2 points. So it's going to be 5 minus 6.2 over 13 minus 9. So you can see I'm going to get a negative answer, and you should because it's decreasing. So when I did it, I got 5 minus 6.2 over 13 minus 9 minus 0.30 meters per second squared. Looking at part C, 15 to 20. So 15 to 20. 15 corresponds to a velocity of 7.5 approximately. 20 corresponds to about 11. So 11 minus 7.5 over 20 minus 15. And let's see, I got around plus 0.70 meters per second squared. Okay. Now, lastly, instantaneous acceleration. So at 15, 11, and 17. So first of all, let's draw the tangent lines. So at 15, here's the 15 one. So maximizing the slope right here, this purple line illustrates that. Okay, so that's what the slope, because you're really maximizing what's happening at that point. So 15 at 11, your tangent line should look similar to this. I believe 11 is right here, so maximizing the slope there, extending that line out, should look like this green dotted one. And the last one here, if I'm not mistaken, it's that flower power one, 17. Yeah, so at 17, right here on the graph, maximizing the slope, so around there. So your tangent line should be a similar shape like that, with the flowers, of course, optional. So pick 2 points on each one of those lines, figure out the slope of those 2 lines, and then check your answers here. Now I chose likely different points than you, so as long as you're in the ballpark or close, you should be okay. If you're really off, be sure to ask me to check your graph, and hopefully I can figure out where you may have went astray here. So the first one I got around plus 2.6 meters per second. Second one around minus a half meters per second squared. And the last one plus 1.1 meters per second squared. Okay, so once again, ballpark figures, if you got close to that, you're like in good shape. Okay, and finally, vocab here, average acceleration. So the term average there indicates that we must have different accelerations, different velocities, so not constant. So acceleration between 2 points in a non-uniform motion on a curved graph. So it implies that we're have non-uniform motion here, so we're finding out the average. And of course, instantaneous acceleration, the acceleration at a specific point on a curved VT graph. So if I was finding the slope at this point here, draw your graph, pick 2 points on there and find the slope. You just don't take this number, the y divided by x number. You have to figure out 2 points and figure out the slope of those 2 points. Okay, that's it. That's it for the acceleration, and we'll see you soon.